We've looked at how our numbers are named, how we take these names in and out of place value, and what I want to look at is how place value itself helps in addition and subtraction, and the algorithms for addition and subtraction. And I'm going to start by looking at quantity in its own right. Right? If I have a quantity of things, and I bring in another quantity of things, right? I've got one group of things and I'm going to use the word, I add more to it. I bring in more. Somehow my quantity grew. We're going to find addition can represent many things depending on what these quantities mean to us. And we're going to find different language in English that in the pattern of mathematics ends up being you're going to add. And so we'll try to find the different words that work for it. But underneath it all, I had a quantity of things. I brought more things into it, and altogether, I have a new quantity. That's what addition does. Addition keeps counting. But what people noticed was I had 3 things. I added 6 things to it. Every time I do that, when I count up the new thing, I get 9. So instead of having to keep the tally marks together, we go, you know what? Every time I have 0 things and I add 1, I get 1. Every time I have 1 thing and I add 1, I get 2. And every time I have 5 things and I add 5 things, I get 10. Every time I have 321 things and I add 91 things, I get 412 things. These are truisms. People used to have to use the abacus. If you look at the videos from the other day, they used to have to move beads and actually count their way through the tallies a lot of the times to do these type of numbers. What our place system did for us was let the place dictate the answer. And I want to admit the book mentions it now, but we won't go into it in a little bit later. We can also think of adding as place on a number line. If you imagine some line that starts out at 0 and jumps like a ruler 1 space for every number, which is going to be called a number line. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you start at 3, we start at 3 and we move 6. 1, 2, 3, 4, 5, 6. And we end at 9. So addition can also be thought of as movement, right? Notice how the pattern in the number gives you the same thing, but the way we visualize it, what we do in our head is different. And that's part of the art of the horrible word problem, but of interpreting reality into numbers, figuring out what pattern you're seeing. And I'm going to use this example here. What place value let us do is it let us kind of look at these numbers in expanded form. Now I'm going to do this in expanded form first, and then we're going to back that into the better way of doing it, the better mechanics. So in expanded form, let me change color for the expanded form. That's 3 times 100 plus 2 times 10 plus 1. That's 321. Plus 9 times 10 plus 1. Alright, so if I look at all the 100s, I only have 3 100s. I have 2 10s and 9 10s. So altogether, I have 11 10s and 1 1, or 2 1s, plus 2 1s, right? There's a 1 and there's a 1, so I have 2 1s altogether. So that means I have 300 plus 110 plus 2, or 412. That's what naming numbers like this let us do. We don't have to count things together. We don't need an external machine. The place value does that for us. But this works much, much better if we use the place value fully. So let me do that. If I 321 plus 91. I'm going to line up the exact same place. The ones are over the ones, the tens are over the tens, the hundreds over the hundreds, and so on. So you let the place value make a visual representation of the quantity. And if I add down, 1 plus 1 is 2. 9 plus 2 is 11, but I can only put the digits 0 through 9 here. So I put the 1, and that extra 1 in the tens place goes over into the hundreds place. And I get 412. Remember, human beings did not do this in Western culture, and we kind of have evidence that there were a few cultures that had place value numbers, but only their mathematicians did it. Only their priests and learned people learned it. The Babylonians had a base 60 number system with place value. Turned out the Greeks had a rudimentary base number system. I think it was base 12 too. It was a slightly odd system. And the Indians had some forms of this, but not everyone did. Most people, when they had to count or add, had to get an external machine that had beads or markers on it to add. This invention and this introduction into Western culture let people be able to add large numbers, and a lot of people developed the skill of doing this within their head. It sounds like not a big deal, but it changed the way people did business. They could keep track of things. They could do things more quickly. It's a small efficiency, but you add hundreds of years to this. You do this over hundreds of years, and you do it across a culture, and you get a large improvement. And so addition becomes lining up place values. 3,592 plus 10,412. Notice I line up the periods as a way, and this is why having good writing to put periods and such in. And so the ones are over the ones, the tens are over the tens, the hundreds over the hundreds, the thousands over the thousands, and the 10,000s over the 10,000s. And 2 plus 2 is 4. 9 plus 1 is 10. So I put down the ones place, and the extra one goes here. 1 plus 5 is 6. 6 plus 4 is 10. Same thing. Right? I have to put the extra one over here. 1 plus 3 is 4. And we have an algorithm for adding. And that's called the addition algorithm. And this was on the 6th page of Fibonacci's Liber Abaci. This ability now that we could do these maths quickly without an outside aid. Now I know everyone has access to calculators. You should endeavor to be comfortable with this algorithm without a calculator and use the calculator to check you. There are certain fields that will still require you to do this in your head, and kind of nursing and a lot of dosage based schools have a requirement to pass certain exams that you can't do it without a calculator, because you need to be able to do the calculations in your head in an emergency. I've worked with many a nursing program where they weren't allowed to have calculators, and they had to get an A in their dosage calculations to continue in the program. And so a lot of the focus was focusing on this, focusing on what the numbers already have, and what the names of things already have that we can use to do the calculations. So instead of it being do A, B, 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 C, it's what does this stuff mean, and how can you line this stuff up so you can use it? And place value lets us do that. Well, addition has